One of the possibilities when we're dealing with a system of equations is that the lines cross. So we're just going to make a sketch of two lines crossing up top. Sounds ridiculous, but it's a visual that may help you at some point. And let's say that the two equations we're dealing with are 4x plus y equals 2 and x plus y equals 20. I'm going to choose to solve this equation using the process of elimination. Elimination. I'll use pen. That might be a lot easier to read. Let me find a pen. Here it is. All right, so I am going to multiply the bottom of the equation by -1. And I'm going to rewrite the system. And I will get 4x plus y equals 2 and negative x minus y equals -20. This is old hat to you guys. We've been doing this for weeks. I'll add the equations together. 4x minus x gives me 3x. Plus y minus y, they go away. That's the purpose of elimination. And 2 minus 20 is going to give me -18. Notice how small we have to write to get all of this in the column. I'll then divide both sides by 3. And I will get x equals -6. I'm going to put -6 in the second equation. X plus y equals 20. -6 plus y equals 20. Add 6 to both sides. And I get y equals 26. The solution, therefore, is -6, 26. So if we go through a set of equations and use a process like elimination, and we get a point, then we know that the lines cross, and that's the point where the lines cross. These two equations, if I graph them, would cross at -6, 26. That's no different than everything we've been doing all along. I'm going to go through this nice and slow because I want you to have everything correct. And you'll be using this as a reference guide on your test.
So y equals 26 then?
Y equals 26, yes. Now, one of the things that can happen is when we graph these, we can graph the first line and it will turn out to be, obviously a line on the coordinate plane. And then when we graph the second one, it lays right on top of the first one. But how do we recognize that when we're using our algebraic means of solving a system of equations? Well, let's see what this would look like. I'm going to look at x plus 2y equals 2 and 2x plus 4y equals 4. And in this case, I'm going to use substitution to solve the system. This, by the way, is also going to be a great example of these processes while you're taking the test. I'm going to solve the first equation for x. X plus 2y equals 2. I'm going to subtract 2y from each side. And I'm going to get x equals -2y plus 2. I just rewrote the first equation so that I can put it into the second equation. Am I going too fast? Is everybody good? Your job right now is to just record and try to absorb what we're doing.
What are the substitution and elimination? What are they like called?
Elimination and substitution.
Like what is it like? Like it's like the system or like the method or?
Yeah, that's the method. Okay, substitution is the method we're using right now to solve this system. Now I'm going to take this and put it into that equation for x. So where I had 2x, I'm now going to have what x is equal to. Instead of x, I'm going to put in my negative 2y plus 2. So that's 2x for this equation plus 4y equals 4. Now I'm going to try and solve for y. I'm going to distribute the 2. 2 times negative 2 is negative 4y. 2 times 2 is plus 4. Plus 4y equals 4. I'll combine like terms. And what I'm going to see is that the negative 4y and the 4y add up to 0. So all I'm left with on the left side is 4. And what I have on the right side is 4. This is a true statement. When you solve a system of equations and you get a true statement, it tells you that the lines are exactly the same line on top of each other.
Is that 4 equals 4?
4 equals 4. And we call that a dependent system. So you're going to be asked to solve 2 equations. You're going to be asked to solve a system of equations on the assessment. Through elimination or substitution, you're going to solve it. And you're going to get 2 numbers that are equal to each other. You might get 2 numbers that are equal to each other. If that occurs, your response to the solution is when graph lines are the same, they share all the same points, and it's called a dependent system. So your answer to the question, what is the solution to this system, would be, it is a dependent system. And you will have this to refer back to.
How'd you have 4 equals 4 if there's y's? So y's cancel each other out? Yeah. So it's possible.
When I did substitution, I got this. Negative 4y and positive 4y. And when I combine these 2 things, they went away. Negative 4y and 4y is 0. All I was left with on the left-hand side is 4. All I was left with on the right-hand side was 4. 4 does equal 4. That means every single point on each line they share. All right. The last column. What can also happen when you graph them is the lines turn out to be parallel. They don't share any points at all. For instance, if we were given the system 2x plus y equals 1 and 4x plus 2y equals 4, I'm going to choose to solve this using elimination.
So you just get to choose, or?
I'm going to use elimination, and I'm going to attempt to get the x's to cancel out. So I'm going to multiply the top equation by negative 2, so that I have negative 4x as my x term on top. Let's see what happens when I do that. Multiply that by negative 2, and I'm going to rewrite the system. Negative 2 times 2x is negative 4x. Negative 2 times y is negative 2y. And negative 2 times 1 is negative 2. I'll put the other equation right below it. In elimination, we add those 2 equations together. Negative 4x and 4x is 0. Negative 2 and 2 is 0. Negative 2 and 4 is 2. I get a statement at the end that says 0 equals 2. This is not true. If I go to solve a system of equations and I get some weird statement that looks like this, 0 equals 2, it means that the lines I were given, the two equations I were given, produce lines that are parallel. And there is no solution. They don't have points that are the same. And the mathematical term for that kind of system is called inconsistent. It is at the top of that column. Everybody good? We're halfway there. Yes.
So, do you just have to decide which one that work, which method will work with it?
Yes, you have to decide what method you're going to use to solve the system.
So how do you know which method to use?
Whatever one you're more comfortable with. For instance, when I look at the first set of equations, my eye naturally goes here. I like elimination better. It's a personal preference. You could use either kind of process on every system. If I was given a system of equations, though, that was something like 2x plus 4y equals 8, and then the other equation was y equals 2x plus 5, I would use substitution.
Why? Oh, because it would be easier to fit the 4y into the...
Right, I just have to put 2x plus 5 in for y. However, with everything I'm presenting to you so far, look how the way the equations are written kind of line up nicely. I would probably choose to use elimination. I only put substitution in the middle as an example of another way of doing it so that you have it down on paper.
Yeah, I think it's easier for someone to do substitution.
If I wanted to do substitution with this system, I'd have to rearrange the equation first and rewrite it so I had negative 2x plus y equals 5, and then do substitution with these two.
Mm-hmm.
All right. Turn your paper over, please. Let's put our sketches in right away. We have three kinds of systems. Either the lines cross, they produce the same line, which is kind of hard to draw, or they're parallel. All right. Now, do you remember, I hope, and you don't have to do these this way, but I'd be remiss if I didn't show it to you. If I had equations that look like this, 4x plus y equals 2, and x plus y equals 20. The same system we had on the other side for this example. But if you remember, when we have equations that are in the y equals mx plus b form, m represents slope, b represents y-intercept. Now, if two lines have a different slope, they're always going to cross. Think of that. Slope is how the line is angled. If two lines are angled differently, they're always going to cross. So if we put our equations into this form and they have different m's, we know they cross.
You did that so long.
We did it a long time ago. And it's going to be revived in Algebra 1 the first day you walk in the door.
I hated that.
All right? So I'm going to solve this equation and put it in this form. I'll subtract 4x from each side. And I get y equals negative 4x plus 2. So in this case, the slope is negative 4, and the y-intercept is 2. That's the first equation. The second equation, I'm going to put it in that form, which always just involves moving the x on the other side. And I get y equals negative x plus 20. So in this case, the slope is negative 1, and the y-intercept is 20. Notice what I said at the top of that column. Different slopes intersect. They have different slopes. I don't know where they intersect yet, but if the only thing you're ever asked is do they, and not asked where they, you can always put them into this form and say different slopes, yes, they're going to intersect. It is a unique solution. The system of equations has a unique solutions. The lines intersect at one point. Let's see what happens. Now, you can imagine if they're the same line, they're going to have exactly the same slope, exactly the same y-intercept. They're going to go through the same place on the y-axis, and then they're going to increase or decrease at the same rate. Actually, when we're done, the equations should be exactly the same. So if I take x plus 2y equals 2, subtract x from both sides, I get 2y equals negative x plus 2. I'll divide everything by 2 so that I put it in the proper form. And I get y equals negative 1/2 x plus 1. Negative x divided by 2 is understood to be negative 1x. So that's where we get the negative 1/2. When I'm done with all that, I find out that the slope is negative 1/2 and the intercept is 1. Now the second equation I'm given, 2x plus 4y equals 4. I subtract 2x from both sides. I get 4y equals negative 2x plus 4. And when I'm done dividing by 4, you'll notice I get y equals negative 2 over 4 is negative 1/2 x plus 1. I got exactly the same equations when I put each one of the equations I was given into slope-intercept form. That means if I graph them, they'd be right on top of each other. Which means in your shoes, if you decide to analyze it this way, they have the same slope, same intercept. They are what's called a dependent system. That's when you graph them and they share all of the same points. We're almost done. Hang in there with me, and then I'm going to summarize everything, and we're going to take a breather. I know it's been a lot. So please understand, take these with the spirit of the fact that you'll be able to use them. And you'll understand them better after we practice using them. After we practice using this guide that you're building. Finally, if they have the same slope, meaning they go, they increase or decrease at the same rate, but go through different places on the y-axis, they have different y-intercepts. They're going to be parallel to each other. So I tried to put this in math terms and in layman's terms. It's an inconsistent system, which means the lines are parallel, which means they have the same slope but a different intercept. All the information is right there. So if I'm given my first equation, and it looks like 2x plus y equals 1, I'm going to put it in slope-intercept form, which is over here. This is what we're doing. I'm going to put it in slope-intercept form and get y equals negative 2x plus 1. So this thing has a slope of negative 2, and it crosses the y-axis at 1. So there's a slope of negative 2. And it crosses the y-axis at 1. So it looks something like that. All right, let's look at the second equation we were given for this system. We were given 4x plus 2y equals 4. I'm going to put it in this form. Got to move the x over first. 2y equals negative 4x plus 4. Now to get rid of the number in front of the 2, I'll divide by 2. I get y equals negative 2x plus 2. This has a slope of negative 2 and a y-intercept equal to 2. So if I were to graph this, it'd have the same slope as this line, but it would go through 2 on the y-axis. So it would look something like that. They'd be parallel. They would never meet. They don't have a solution. They don't share any points at all. And all that information is here. Same slope, different intercept. Same slope, different intercept. They'll spend the rest of their lives next to each other but never touching. Got it? So, what have we done? On the front, if you decide to solve a system of equations with elimination or substitution, you can see that you can get a solution. You can get a point where they cross. You can get something that looks like this, where you have two numbers or two terms that are the same, set equal to each other. That means that it is a dependent system. They're the same line. Or when you solve the system, you can get an untrue equality. 0 does not equal 2. That means that the lines are parallel, they'll never meet, and the system in mathematical language is called inconsistent. You can always do that. You never have to do this if you don't want to. But this is another way of identifying whether a system is unique, dependent, or inconsistent. If you don't like this thing, if when you close your eyes at night and this is a nightmare to you, then don't do it this way. It's not bad practice though, because it's going to come back to you in Algebra 1. Everybody good with this? I'm going to post this. All right, well, we're going to make sense to you. This is the absorbing the information point of this lesson. All you're supposed to do today is get exposed to